So here we have a Harbor Freight angle grinder that has decided to stop working. I was cutting some aluminum, 3/16 aluminum sheet with a zip cut aluminum oxide cutoff wheel, and she quit. And I knew she was running hot, but I had a job to finish. I was surprised that the $30 angle grinder did come with a set of replacement brushes, but I don't think we will need those today, as I don't think it's the brushes. And now that we've got the screws off, we're having a fun time prying off the cover. And we're in. We've got a nice inside coating of manufactured rock dust from when I was doing stonework. There's a switch that has a nice positive snap action. And here are our brushes, which I don't think are bad. Clip right in there with our little positive retention. And we have some mild pitting in the brushes, but I'd fathom that that's just cheap graphite and fine, and I don't think we're going to have any issues on the other side. Let's go ahead and check this switch. It's a common failure point in these cheap tools is this switch. I'm going to put her into continuity. That side of the switch works. And that side of the switch is normally closed. I don't see a problem there. Go ahead and clean some of this dust out of here while we're at it. Now look at that. On this side, we got these chintzy little blade connectors, and that might be our problem. That there is our problem. Why this tool has failed to run. Yeah, I should be using the right tool for the job. But, what can you say? Kids always cut towards yourself. And here we have a Jiven FA251 6 amp 250 volt 10 amp 125 volt switch. So in North America at 120 volts, this is a 10 amp switch, which should be plenty for this cheap little grinder. This is a surprisingly nice switch for a $30 angle grinder. Nice, quick. And we've got more of these crimp connectors on this side, screwed in this time, not on these types of terminals. But yeah, this blade connector, whatever you want to call it, has given up the ghost. Surprisingly, that doesn't seem to be a result of overusing the tool. This is just cheap parts, bad manufacturing. I'm really surprised. She was getting really hot in my hand when she blew. I was certain that something, it was like a commutator desoldering or delaminating or something bigger burning, but this is a nice surprise. Get some more life out of my $30 grinder. So here I'm just cleaning off some of the excess dust that has accumulated inside the grinder over its roughly 2 years of infrequent use. Now I am getting the remainder of the crimp connector off of the wire, and I'm doing this in the most unsafe way possible. Remember kids, always cut towards yourself. And then this is me giving up and just cutting it off. Well, in the words of Gridner vs. Evil, if it ain't broke, take it apart and fix it. I am curious to see what is inside a $30 angle grinder. So we're going to unbolt the differential, the bevel gear head here. And we have commutator, pull out. Here we have a shielded 627Z bearing, NBKJ. Okay, Chang Hongyi axle, factory in Ningbo, China. Here we have the field windings with some balancing cuts. Well, at least they tried. It does run relatively smoothly. Here we have the commutator. Given the abuse it's gone through, it's in pretty good shape. Let's take off the arbor nut, this back plate, pull out the brushes. And this little nitrile vibration dampener fell out of the back. Here, at least they tried. Ooh, that's toasty. Okay. That was not the only issue with this. Okay, well, I'm glad it wasn't as simple as a switch connection failure. We have some serious corrosion on this brush holder. That is why these blade connectors are not the best idea. They have their use, but not for connecting high amp brushes. They are cheap though. Knock off some of this rock dust that's accumulated. And that's not coming out anytime soon. But this is a problem. There's no copper left in that wire. So this blade holder must have gotten so hot that it melted the copper and it just oxidized away. Easy fix, hopefully. Okay, so we've got our shrink tubing, and we got 1/8 shrink tubing here, which is a little big for this, but it's the smallest I've got that'll fit. And we have our trusty Met Cow heated up already. And our leaded solder. I only buy leaded solder. Yeah, it's bad for you, but nothing flows like lead. There we go. Nicely flowed joint. And I don't feel like busting out the heat gun, so we're gonna do it the lazy way. And this is what happens when you're careless. You get solder all over the place. I don't remember if there was any heat shrink over that. I only use clear shrink tubing because that way you can always see the joint underneath. Besides, who needs pretty colors anyway? So inside there we have our field windings and that's it. The stator, brush holders, and the little holder for this nitrile rubber vibration dampener all the way in the back, into which are bearing seats. Good grief, how am I going to get that back in? To here we have our fan to provide some cooling, minimal cooling, obviously. There we go. Not even an O-ring seal. Just looking at the surface finish of these gears, it's pretty rough. But inside there we have a roller bearing that rides along the arbor shaft, and there's our lock pin that indexes into these 4 lock pin receptacles in the bevel gear. Actually, it's not really a bevel gear, it's more of a hypoid gear going on. The teeth are curved and these teeth are curved. This grease is a sore disappointment. You can tell that it all gets pushed up to the top there and it's not actually sticking to the gear at all. The gear is bone dry, that gear is bone dry, and all our grease is stuck up there. So that is not conducive to good wear, and you can see all the schmoo from wear in the gear. That's probably why the surface finish isn't as noticeable. So we're going to take...
And this is just cheap soap grease, nothing special. No moly disulfide or graphite here. You get what you pay for. I think this was 30, 39, 40 bucks, so nothing much. Ooh, that grease does us zero good up there. And I fully expect that the next use this grease will all get flung up top. Again, but can't say I didn't try. Ideally this head would be packed with grease, but
I don't know what kind of soap this is, and I don't want to spend hours with solvent cleaning all this soap out, which is what you need to do if you want to replace it with your own grease, because you don't know if the soaps are compatible with each other, and if they're not, you get a lovely leakage coming out of this gasket, especially because there is no gasket here, just a metal-to-metal surface. Here we've got some aluminum slash pot metal casting, who knows what that is. So now we get back to this wonky little switch. And we have a no-go. Ha 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 ha. Ha 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 ha. Well, that would explain our failure of operation. So I got this brush pushed in here, but if you can see inside, the brush is not poking through to the commutator. Rookie mistake. There's a little indexing groove on the brush, and I thought that indexing groove indexed on this side where there's this little nub, but I was wrong. The brush holder has an index nub on the inside bottom side, so we'll brush both brushes out and do this again. Perfecto. Alright, second time's a charm. Ooh. That's not a good sound. But she works.